All right, ladies and gentlemen, let's talk about part two. So again, our friend transformation comes back on the final as well. How about that? Go figure. So we have this mapping, and it's actually all done for you. So your job is actually just to describe what's happening. It does get confusing, kind of seeing this whole combined diagram, but I'm trying to use colors to help kind of delineate what's going on, and I'm trying to number my steps as well. So really, what's going on is I have this triangle JLF, and I'm transferring it in one, two, three steps to triangle MRC. So that's the goal here. So we have to kind of figure out what's going on. Now we're going to do this a couple different ways. One, we're going to try to track it one step at a time, and we're going to ask ourselves, well, which rigid transformation is actually occurring in this particular case in step one, going from JLF to ABC. Um, so we can do this a couple different ways, but in the end, it really just has to be a sight recognition. You have to realize that this triangle is actually sliding down and to the right across our paper, and if it is sliding without twisting, without flipping, well, that's going to be a translation. So in terms of explaining this, you could do a couple different things. You can simply, down in this box, tell me it has been a translation and how it's been translated. But guys, it's just as easy to write this as a rule. Like that's why the whole point of the rule is to take all that information by saying it's a translation of JLF to ABC along vector LB and put it into one concise rule. So the rule should not be confusing. The rule is actually just like four sentences combined into a single sentence. So we use a T to indicate it's been a translation. We have to indicate the vector along which it's translating, and it doesn't really matter which vector you use. You just pick one. Like one of the properties of translations we studied was that all these vectors are the same anyway, so you just simply pick one. I'm going to pick LB. So I'm going to translate along the vector LB. Now I gotta tell what's being translated, the preimage, in this case triangle JLF, and I'm gonna take it to my new triangle, my image triangle, ABC. So that statement alone tells you everything you need to know about how this thing is actually moving. So it tells you what it is, translation, what you're translating on, and where it's going. So it's telling you four different things in one nice, concise sentence. Can you write that out if you want? Sure. You don't have to, though. Here's step two, indicated in red. So I'm taking in this blue triangle ABC. This is now step two. And if you look at the arrows, I'm now moving it up to the green triangle MDC. So now the question is, well, what happened? Well, it certainly didn't slide. It certainly didn't reflect. Hopefully you recognize this as a rotation amount point C. So now that's what we have to write. So we have to record that. So it's going to be a reflection, a rotation. So I'm going to use an R to indicate rotation. We have to indicate the point of rotation, the only point that's not moving, which is C. We have to indicate the angle of rotation. Now this is the part that I know is messing people up. But remember, the angle of rotation is defined to be between a pre-image, center, and image. So to define a angle of rotation, all we have to do is define those three things. In other words, we were rotating point A about point C, and it's going to end up at point M. So the angle of rotation in this case is angle ACM. Now you don't have to just use ACM. Certainly you can use kind of whatever you want. What I mean is it'd be equally good to say the angle of rotation is BCD. Because you notice like that's actually the same angle. I had to shorten the lengths a little bit, but that's kind of expected. And point C doesn't move, so I can't use that. But again, I can either name this angle ACM as my angle of rotation, or I could name BCD as my angle of rotation. It doesn't really matter which. I just use ACM because frankly it was the first one I saw, and there was no other reason than that. Okay, so again, let's not freak out about the angle of rotation thing. It's just telling you what point the center and what point it's moving to. Back to our rule, so we're rotating about center C by angle ACM. Let's let's go ahead and record what we're rotating, in this case triangle ABC. And we're going to end up at I'm going to drop this below. Oh, no, I can probably fit in there. I'll end up with triangle MDC. Okay, last bit, we have the green triangle. We now have to move it to the triangle MRC. So in this particular case, it's going to be the result of a reflection. Clearly, it's not actually moving, but along the green line, it's flipping. So now we just have to record that. So let's go ahead and get into it. Lots of ways you can use reflection. I'm going to use a little R. That's one of the many symbols you can use for reflection. We have to note the line of reflection. And if you look right here, that is a line of reflection. It's going to be MC. We have to tell what we're reflecting. So in this case, triangle MDC. And where that's going will be triangle MRC. Okay, so hopefully this is kind of repetitive, but that's how I expect that particular question to be answered. Now, you didn't have to use the rules if you didn't want to. You can actually write all those sentences out, but the point of the rules is it collects all that information into a nice, tight, and concise way to write it. So that's why we have it. So here is a kind of related question. So instead of having the mapping done for you, I actually want you to perform a mapping. Now I'm not going to do this, and the reason why I'm not going to do this formally, I may kind of informally show you one, is that there's so many different combinations of what you could do. So the one thing we kind of studied in depth was that um, if you have this triangle and you want to use a series of rigid, i.e. not non-congruency based transformations, um, there's a lot of different ways you can do it. Now, there are some techniques that work really well. One technique I like to use is to first do a translation. So I have like 2 points aligned right away, and that gives me a point of rotation where I don't have to actually move. So like I can move A to D. The next thing I like to do is to rotate in place. And again, this is just a technique. So I can just rotate this along D in place. Oh, I got kind of wild there, didn't I? And so my last move is a reflection. Like that's just my kind of personal tactic. You can frankly do whatever you like. I'm not going to map one out here because there are so many possibilities. But when you do start mapping this out, make sure that you're including all these steps like I am up here. All right. So I'm not gonna go in depth through one of those. I do have a video for the previous test that had like 3 examples of this. So I'm not gonna go ahead and take your time and do it here. All right. So I'll see you guys in the next part if you're watching these. Thank you.